This is my modified complex circuit on the Arduino. Right here you will notice that this is not actually an ultrasonic sensor that I have in my actual real life Arduino complex project. That is because Fritzing does not have its own ultrasonic, so I had to use an infrared sensor. But it works basically the same way in the way the pins are sorted and like how much power it needs and everything. So for this infrared, and just like the ultrasonic, it needs 5 volts of 5 volts of electricity coming through from this Arduino spot that goes into the infrared. It also has a grounding wire right here, and right here is the, as it's labeled on the ultrasonic, the SIG, which means signal, which tells it how far away the object actually is from the ultrasonic, and that goes into pin 10, as you can see there. And then right here, these 2 wires connect the 2 breadboards, this being a 5 volt to connect 5 volts to the other side, and this being the grounding wire to connect the grounding wire to the other side. Right here is a potentiometer that regulates the brightness of this LCD screen, and right here's the grounding wire for it. Right here's the 5 volt power wire. This just connects the potentiometer to the LCD screen. Right here's a grounding wire. Right here's a 5 volt wire for the electricity. This is another grounding wire. Right here, the power goes into through the LCD into the resistor, and that regulates also the brightness and how well the LCD screen works. This is another grounding wire. Each of these long red wires are wires that connect into pins that help the LCD screen work. This long one connects into pin 12. This other one connects into pin 11. And so on and so on. That's how it works. And this is my schematic for it. It is basically the same way the Fritzing breadboard is oriented. All of them are connected. All of them have 5 volts connected to them. All of them have grounding wires connected to them. It just looks different to make it a little clearer to a reader that would understand this better. This is just a normal 100 ohm resistor. This is the ultrasonic / infrared. And this is the potentiometer. This LCD screen is connected through all the same ports, same with this Arduino Uno, and everything is basically the same way as before. And that is how my modified complex circuit actually works. This is my modified complex circuit. It's being powered by this wire that is running around into the tablet that I am recording this video on. It is an Arduino 101. All the electricity is connected through that into all the different stations. This LCD screen has a setting that I put in it with the potentiometer that I can turn the brightness up and down. It is being powered by a variety of pins that send electricity through it and into it, and then all these go into a ground wire that is connected to this board that grounds the whole circuit. This ultrasonic has 3 pins connected to it. It has one pin 10, it has a 5 volt pin, and it has a ground pin in it. And there it goes. Now, as you can see here, it's at 60 inches away right now. If I move this box in front of it, it will go back, and the closer I move the box, the closer it will read. to the ultrasonic sensor, and that is how my complex circuit works. This is my complex modified program for the Arduino. It is run with an ultrasonic and LCD screen. As you can see right here, it has two variables in it. One's pin, which is what pin the ultrasonic is set in, and the other one's all the pins that the LCD screen or liquid crystal has. In this program uses case switch, which is a type of program where you pick the switch, which is a variable, and then the case is by numbers, by each separate number that goes to. Like here, I have switch is inches, so how far away in inches the object is from the ultrasonic. It will go in that case and print out what it wants it to do in that specific case. And then I only have up until case 10, and then after that it's the default, so when it's farther away than 10 inches, the switch case automatically sets to this, and then it just tells you how many inches are actually away from the ultrasonic at a point in time. And the LCD screen prints out how many inches away the object actually is. So it takes the reading from the ultrasonic and prints it onto the LCD screen, and it changes over time. Alright, here's my serial monitor. It's showing that right now an object is 31 inches away from it, but as soon as I move an object closer, like that, it prints out the specific variable of where the object is at and how many inches away it is from the actual ultrasonic. And that is how my program works. Through different LCD screens and ultrasonic, that's how my program works and is made.